I'll put a whole bunch of stuff on the class page also about nomenclature. The stuff I posted for CP Chem, I'll just post on our page just in case you want to go back and review any of the rules for nomenclature. Nomenclature, naming things. I gave you a sheet front and back. I want to go through that today. And then I want to start talking. Okay, first of all, here's the layout for how I envision the week going. We're going to go over this polyatomic business, multivalent cations, all that good stuff today. Make sure you understand it. And then we are going to learn how to name acids. And then we are going to learn how to name covalent compounds. That's going to be this week. So our quiz on Friday will be just naming things, nomenclature. By next week, though, we are going to get started into balancing chemical equations, learning the several different types of chemical equations that we have to understand. And then from there, we're going to jump off and go right into stoichiometry, learning about the mole and all kind of good stuff like that. Let me just close the door. Gotta keep Mr. Phillips out when we're videotaping. Videotaping. What year is this? All right, pull out your sheet. So let's go through these rather quickly. And okay, you're always going to need a sheet of polyatomic ions. What for your quizzes and whatever else. What I'll do for you guys is I'll just print off a sheet, and that way you can keep them with your periodic table and keep them with your other pieces of your toolbox. Eventually, you just know these things. I mean, you use them so much as a chemist or in chemistry that you know that sulfate is SO4 with a -2 charge. You know that sulfite is SO3 with a -2 charge. You know that perchlorate is ClO4 with a -1 charge. You just know these things when you use them. Like this is a lot like taking Spanish class or French class. On day, week 3 in Spanish, you're not going to be, hablando el español perfectamente, right? You're going to be like blah, 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 como estás, and all that stuff. So we are learning the vocabulary. So let's go ahead and do it. Estoy hablando el español perfectamente. Oh, it's going to be, no one in here is in the cooking class, are you? Yeah, you're in the cooking class. Good. And you're in the cooking. Okay. It's next week starts Hispanic Heritage Month. So we're going to be doing some cool stuff, empanadas and things like that. I'm excited. Today we're going to make dough for the pizza, and it has to rise overnight. So you guys will make the dough for tomorrow's group. Tomorrow's group will use your dough to make pizza and make dough. So then on Wednesday, you guys, well, we're going to leapfrog the dough making process. So by the end of the week, we're going to be all pizzaed out, if that's possible. Okay, back on track. Na2CO3. Now, Na, sodium, has a +1 charge. Carbonate is CO3 with a -2 charge. So if you're going to write this formula, it's obviously going to be Na2CO3. Okay. Now, don't get in this weird habit of saying, "Oh, I'm going to make up my own names for these things. I'm not going to call it sodium carbon oxide." No. You go to the chart, you find CO3 and say it's carbonate. That's just its name. You don't have to change its name. It's not like phosphorus going to phosphide. So how about I write this? What if I write SODIUM1?
Mr. Canfield, come to the main office. Mr. Canfield to the main office. Thank you.
Who's Mr. Canfield?
Oh, he's a son.
Oh. All right. Right, wrong? Right, wrong?
Wrong.
Wrong. Good.
That is wrong.
You never puts a Roman numeral if it only gets 1 charge. So let's get rid of that. Sodium carbonate. Good. As opposed to this, which we're going to be using in the kitchen. This is sodium bicarbonate. We'll get to that when we get to that. All right. Moving along here. Number 2, just tell me, what is it?
Sodium hydroxide.
Sodium hydroxide. Perfect. Number 3.
Magnesium bromide.
Magnesium bromide. Very good. 4.
Potassium chloride.
Potassium chloride. 5 might throw you for a little loop.
Iron.
Roman.
You guys got it. Yeah. Iron.
Oh, I'm saying
Iron 2 oxide. How about number 6?
Wait, it's chloride.
What?
Wait, I thought it was chloride.
It is chloride. It's Monday. It's Monday. FeCl2, right. How about FeCl3?
Iron 3 chloride.
Yeah, same thing, but I have a 3 there. Ooh, let's see if you get number 7. Zinc is right. Do you need that too? No, because the only charge zinc ever gets is 2. We don't want to be redundant. Zinc hydroxide. How about it? Yes.
So the ones with like the number in the box never have like that.
Yep. All of your other transition metals, copper, nickel, cobalt, iron, etc., we call them multivalent or polyvalent cations. They can get different charges depending upon the compound. But silver will only ever get a +1 charge, and zinc will only ever get a +2 charge. Yeah. Zinc is really interesting. It's certainly necessary for us to have a certain amount of zinc in our bodies. Purportedly, it helps your immune system if you take zinc. But have any of you ever traveled down near Allentown, Pennsylvania? And yes, and driven down, what is it, the Turnpike, right? And there's this town called Palmerton. I don't know if you ever saw it. It's like, but when you're heading down, and it used to be all devoid of any sort of foliage because they were doing zinc mining, and the zinc. If you look at magnesium +2, magnesium +2 is an ion that's in chlorophyll, and the zinc is about the same size, so it can replace the magnesium in plant life, and then the plants will die. They can't live with zinc in there. So it took many, many, many years for them to get the grass to grow again. In that town of Palmerton, like I said, it was a zinc smelting town, and they would, instead of having grass, they would paint gravel green in their front yard. They never had to mow it, which was a good thing. Couldn't roll around in it. So, where was I before I diverged? BeSO4,
Beryllium sulfate.
beryllium sulfate. Yeah, sulfate. How about number 9?
Chromium 2 chloride.
Chromium 2 fluoride, yeah. I should have you guys saying it on the video. All right. You're giving all the answers. You don't want to see me up here. Chromium 2 fluoride. How about number 10?
Aluminum sulfide.
Aluminum sulfide. Number 11.
Lead 2 oxide.
Ah, very good. Very, very good. Lead 2 oxide. Okay. 12.
Lithium phosphate.
Lithium phosphate. 13.
Titanium 4.
Titanium 4. Exactly. Iodide. How about number 14?
Cobalt 2 nitride.
You guys got it. Yeah. And again, if I look at this formula, right? And let's say you're a little bit confused, you can always do that. Wait. You can always do that little thing there, and you get your cobalt 2 nitride. 15.
Magnesium phosphide.
Magnesium phosphide. I'm hearing a lot of answers over here. I don't hear too many over here. So, how about 16? Gallium nitride. Perfect. 17.
No 3.
Silver. No 3. Because it's actually in group 13. So aluminum gets a +3, and gallium, when it becomes a cation, we get a +3. Good question though. How about we have our old friend with 2 polyatomic ions? What are we going to call that one?
Ammonium hydroxide.
Ammonium hydroxide. Good, Layla. is one of my favorite ones. Aluminum cyanide. Yeah. Now, this last one. Beryllium. And then I had this in parentheses. What are you going to call that?
Acetate.
Acetate, right. Now let's look at acetate for a moment. Sometimes you see it written this way, okay? Now watch. And sometimes you see it written this way. C2H3O2 with a -1 charge. Both of these are correct. But you might be saying, well, how come sometimes you write it like this and sometimes you write it like that? Well, I'm going to give you a little bit of information here. Acetate comes from acetic acid. Acetic acid is vinegar. Well, it's in vinegar. Vinegar is a 5% solution of acetic acid. Now, we're going to learn that when that ionizes, when we get to the acid-base chapter, you will get CH3COO with a minus charge plus a hydrogen ion. It's actually in equilibrium. You don't know that yet. But this is the what we call the conjugate base of the acid. This is acetate. And then you can form that into a salt. For example, you could have sodium acetate. And as a matter of fact, we'll be playing with that a little bit this year. But acetate comes from acetic acid with the proton removed. And the reason they write it like this, with like that COOH, is because it's like a condensed structural formula. Because the real structural formula looks like that. And this is just trying to show you, I've got this CH3 group, this is called a methyl group here, and I have the carbon bonded to two oxygens, that one, and then that oxygen is bonded to VH. So that's why we have two different versions. It's the same thing. So either way, as long as you recognize it. So good. And going on the back side of the page, sodium phosphide, I get this. Double check, Na3P, magnesium nitrate. You need parentheses because you need to show that you have two nitrates for the magnesium. Page.
Okay. How do you get these numbers?
Which numbers?
Like the 3 and the first one and then the 3 and the
Oh, okay, good question. Between the periodic table and that chart on whatever page it was on, you have to look at the charges. So magnesium is in group 2. Okay, it's an alkaline metal, or alkaline earth metal, and we learned that they all get a +2 charge. Now nitrate has a -1 charge. Now when you write the chemical formula, you want to make sure that when you combine these two, that you have no charges. All the negative charges cancel the positive charges. So I say, well, I've got two of these, a +2 here, and I have a -1 there, so I'm going to need two of those to cancel that +2 charge.
Okay, where did that 3 come from?
This?
Yeah.
Well, that's just part of the game. That's just part of the package.
Okay.
If you look at your chart, nitrate is just NO3 with a -1 charge.
Okay.
Yep. So that's why that chart of polyatomic ions is so helpful. It takes all the guesswork out. You just write it just the way it is, or if you recognize it for that, you write its name. So it's pretty straightforward. Okay. Lead 2 sulfite. Now let's go again. Like sulfite is SO3 with a -2 charge on it. And that, you don't have to guess, just comes from your table. Lead 2, that means that lead has a +2 charge on it. So luckily, that has a +2, that has a -2. So there's your chemical compound, lead 2 sulfite. Oh my goodness. Chugging along here. Oh, we're already at 14 minutes into the video. So let's go ahead here and calcium phosphate. Well, calcium is +2. Phosphate is -3. Now, if you get confused about this, you can go ahead and do that thing with the numbers, or you can think about the lowest common multiple. So I'm going to need 3 calciums, and I'm going to need 2 phosphates. And again, that's just putting things, subscripts in to give you the proper number of each so that the charges cancel. Hey, ready? Ammonium sulfate. Ammonium is NH4 plus 1 charge on those. I'm going to need 2 because I know that sulfate has a -2 charge. And again, this becomes, the more you do it, the more you look at those charts, the better off you're going to be. Silver cyanide, +1, -1. There's your chemical compound. Aluminum sulfide, Al2S3. Why? Because aluminum gets a +3 charge, so I need 2 of them. Sulfide gets a -2 charge, so I need 3 of them for there to be a +6 and a -6. Beryllium chloride, BeCl2. Arsenide is not one of those compounds that we are, not one of those anions we're going to talk about very much. But if you look at arsenic on the periodic table, it's number 33. It's in the same group as nitrogen and phosphorus. So just thinking along the lines, if I've got copper as my cation, well, arsenide is going to be the anion. It would get a -3 charge, just looking at the other elements in that column. So I'm going to get that strange looking formula. Again, not one that we talk about too much in this class. Arsenic, gallium. We don't spend a lot of time with the metalloids in this class. Hey, right. Where were we? What number was that? 30? Okay, very good. 31. Iron 3 oxide, Fe2O3. And you can prove that to yourself. Gallium nitride. Well, gallium is, if I look, it's right below aluminum. So if I had a guess, I would have to guess that that's going to get a +3 charge. And I know that nitride gets a -3 charge. So there's my formula for gallium nitride. Iron 2 bromide. Okay. Don't make this mistake. I've seen it happen. People get nervous on a quiz and they take this and for some reason they write this as a formula. Don't do that. That's bad. But I've seen it happen. Vanadium 5 phosphate. Vanadium gets some really unique oxidation states or charges. So vanadium is a 5 and phosphate is a -3. So play that game. The 3 comes down there, the 5 goes down there. I need parentheses. Okay, because the least common multiple is 15 for those two. Calcium oxide, that's easy. Calcium's +2, oxide's -1. Magnesium acetate, we just learned acetate's a -1. I can write it like that. Aluminum sulfate. Well, aluminum is a +3, sulfate -2, so Al2SO4 3. Copper 1 carbonate. Well, copper's +1. And carbonate is a -2. So there'd be your formula for copper carbonate. Barium oxide. Barium's +2. Oxide's -2. And we're all good. Ammonium sulfite. Okay, got a couple polyatomics here. Ammonium is NH4, has a +1 charge. Sulfite is SO3 with a -2. So I'm going to have to put parentheses around that ammonium. And there you go. There's my formula. Silver bromide is AgBr, +1, -1. Lead 4 nitrate, or lead, +4 charge. Nitrite rather, has a -1 charge. So there's my lead nitride. So hopefully you got them. And